Hi, this is Becca, and this is Try Tutoring's lesson on solving exponential equations. First, if we want to go through and solve exponential equations, it helps us to know how to simplify exponential expressions. So looking at some rules here for how to rewrite and simplify exponents, if I have a negative exponent, it actually makes it the reciprocal of whatever I'm working with. So essentially, I want to flip whatever has a negative exponent. On this first one, I have 1/4 to the negative third. So because it's a negative, I'm going to flip it so that it's 4/1, still to the third. Well, 4/1 is just 4. So for my simplified answer, I'm going to write 4 cubed. Now, I don't have to calculate what that is. I really just want to leave it in this simplified form. On the next one, we have 5 squared times 5 to the p plus 1. If you are multiplying the same base, so the base number here is 5, it's that big number in your exponential setup. If I'm multiplying the same base, then I can actually add together the exponents. So in this case, my exponents are 2 and p plus 1. So if I add these together, look for like terms. P doesn't have a like term, but 2 plus 1 together makes it 3. So I would call this 5 to the p plus 3 in simplified form. On the next one, I have 7 squared, all taken to the 10th. If we have exponents that are put onto other exponents, in this case we have the 10th going on that 7 squared, we actually multiply. And a lot of times the setup here, you'll see it written with those parentheses. So if you see a parenthesis with those exponents, you're going to multiply them together. So this actually simplifies down to 7 to the 20th. I do 2 times 10. And for the last rule to remember, if you have a 0 exponent, like I have 29 to the 0, it actually makes it a 1. Anything to the 0 is 1. This can be very helpful if I'm trying to rewrite something so that I have the same base on both sides, like we're about to see when we're solving. So if I'm trying to have the same base and I have a 1, well, I can make it something to the 0. So anything to the 0 is 1. So now let's apply it to some solving questions. As I'm solving exponential equations, I'll be looking to find a variable that's most often in the exponent. Now, as I'm solving these, it's helpful for me to have the same base on both sides. That's how I can know those exponents are equivalent. So on the first one, I have 9 to the 2x equals 9 to the negative 2x minus 1. The only way that those 9s can be equal is if those exponents are equal. So because I have the same base on both sides, I can actually just take my exponents and let those be equal to each other. So I take 2x equals negative 2x minus 1, and now I solve. I would add the 2x over to the left side. So I get 4x equals negative 1. And then I would divide by 4. So I have x equals negative 1 over 4. And that would be my final answer for the exponent there. Well, the variable there. You can check it by filling this in to the original equation, so making x on both sides into that negative 1/4, and seeing that I get the same value on both sides. On the next one, I have 11 to the 2p plus 1 times 11 to the p plus 2 equals 11 to the 6th. Now I want to use some rewriting skills first. So on the left side, notice how we have the same base that's multiplying. That means we want to add our exponents. When that same base is multiplying, we want to add our exponents. So adding together here for the exponents, I have 3p plus 3. This does not change the right side. Well, now I have 11 to the something equals 11 to the 6th. For the both sides to be equal, I would need those exponents to be equal. So we've got the same base. let's just figure out what happens if we make these exponents equal. So 3p plus 3 equals 6. I'm going to subtract the 3 over. So I have 3p equals 3, and then divide by 3 to get rid of that coefficient. So p equals 1 is my answer here for the variable. For the last two equations, notice that we do not have the same base on both sides. On the first one, I have 2 to the k plus 1 equals 32. My first goal is to try and make the same base on both sides. A lot of times this means I could use the smaller number. So I see that I have a base of 2 and I see that I have a base of 32. I probably want to use a base of 2 on both sides. So I wouldn't need to change the left side, but I'm hoping I can rewrite the right side as 2 to the something. Well, if I go through and check it out, maybe I guess and check, or maybe I already know this, 32 actually equals 2 to the 5th. So I just want to change this 32 into 2 to the 5th, and now I see that both sides of the equal sign have the same base number, in this case, base number 2. So we use the exponents equal, k plus 1 equals 5. Subtract the 1 over, and I have k equals 4 as my final answer. On the last one, I have 3 to the 5th equals 9 to the x. So I'm thinking I'd like to use 3 as my base number here. It's just the smaller number. And a lot of times it makes it easier to rewrite because that could go into the larger number. So 3 to the 5th equals 3. How can I change this 9? Well, 9 is the same thing as 3 squared, but I've only replaced the 9 part of it. I haven't replaced the x, so I still need to bring down that x as part of my exponent as well. So I can rewrite this as 3 to the 5th equals 3 to the 2x, changing that 9 into a 3 squared. Now that I have the same base on both sides, I let those exponents equal. So let 5 equal 2x. To get x by itself, we divide by 2. So that for my final answer, I have x equals 5 over 2. And that's it. So hopefully this was a good review for you, going through some rules for rewriting those exponentials, knowing how to simplify and combine some terms together, and then seeing how we can apply it so that we can solve exponential equations. So thanks for listening, and we'll talk to you next time.